It was Pi Day last month, and call me an idiot for not releasing this video then, but I'm just not a math nerd. I'm an engineer, and all this hype for a mathematical constant goes a little over my head. Internet drama has been born out of people for and against pi. A quick search of YouTube will yield tens, literally tens, of videos teaching you how to memorize the digits of pi. The Guinness World Record for reciting pi with the most digits has changed hands multiple times, with the current champion, Rajveer Manna of India, managing 70,000 digits in 10 hours. Fair play, Rajveer. Fair play. You finally made it. Now he can use that brain for something actually useful. Jokes aside, this is a genuinely impressive act of memory. Pi is a fascinating mathematical constant that defies any tricks for memorization. It just keeps going and going and going. God, it just keeps going. It's infinite and it doesn't repeat itself, so you just have to brunt force memorize it. And while these lads are spending days learning as many digits as possible, mathematicians are working away at calculating the new longest string of digits. Pi is found fairly simply by dividing a circle's circumference by its diameter. So, the diameter of a circle can fit into its circumference 3.1415926535897932384626433832795. Okay, so you get the point. That is simple on paper, but in practice it is far more difficult. Measuring a circle's circumference accurately is practically impossible. Even your best attempts with a measuring tape will be off by the thickness of the measuring tape. Archimedes was the first to calculate pi with any level of accuracy with an ingenious method called the method of exhaustion, and yes, it's nearly as exhausting as this video's attempts at snarky humour. He started estimating pi with squares, which sounds unconventional, but it makes a lot of sense. In the mind of Archimedes, a circle was simply a polygon with an infinite number of sides, so by starting with a polygon with fewer sides, we can get a rough estimate of pi by calculating its ratio of circumference to diameter. Let's start by placing a square inside a circle with its corners touching the circle's sides. We can then find the ratio of this low estimate of pi by dividing the sum of the square's sides by its diagonal diameter, which in this case is 2.828. This is our low estimate of pi. Now, let's place a square with its sides touching the circle's side, and this time we will divide the sum of the square's sides by the length of one of the square sides, which gives us 4, the number of sides a square has. In both of these cases, we are dividing by the circle's diameter. That figure is accurate. What we are lacking in accuracy is the measurement of the circumference. The inside square's perimeter is too small, and the outside square's perimeter is too big, but now we know pi lies between these two numbers. Now we just need to narrow it down, and we can do that by increasing the number of sides of the polygon. Each time we add a side, those figures will get more accurate, and eventually the two numbers will start overlapping in their digits. This is how we got our first known digits of pi. This continued on for a couple of centuries, with mathematicians out-exhausting each other until eventually someone started using computers, and now we're just exhausting them. We now have 2.7 trillion digits of pi calculated, and for some reason through these millennia, an engineer never stood up and yelled, "Stop! For the love of all that is holy, stop! We have enough digits, we don't need any more! We don't have any circles big enough to justify this level of accuracy! Go to bed, you lunatics!" Because in the end of the day, that's what pi is used for. It's for calculating the circumference and area of circles, it's for converting degrees to radians, and this is where the arts of mathematics and engineering differ. While mathematicians obsess over accuracy to the trillionth digit, engineers aim for good enough. And good enough turns out to be 3.141592653589793 for the people that work with the biggest circles, NASA. Let's take the distance to Voyager 1, which is currently 21.7 billion kilometers away in interstellar space, as our radius. Say we want to calculate the circumference of a circle with a radius this large. What difference would adding one extra digit of pi provide? That's the difference between 15 decimal places and 16 decimal places. This is actually tough enough to calculate with a calculator or Excel, as both are limited in the number of decimal places they can calculate to. So, using this online high-precision calculator, we can find that the circumference of this circle will be about 136 billion kilometers. And if we use one extra digit, it will be 8.67 millimeters closer to the actual value. That's tiny, and we just traveled out of the solar system. That's why JPL and NASA don't need any more figures, and the chances are you don't need any more than 3.1416. So, I'm going to be that engineer that yells stop. Please stop. We have better things to be worrying about. Pi is literally infinite and we are never going to reach the end. What is the point? If you don't want to waste your life completing pointless challenges,